Every single click leaves a permanent digital footprint across the global web. Public networks expose your private information to completely invisible network onlookers. But commercial apps often promise total, absolute invisibility with one click. How does software actually protect data moving through public infrastructure? Without protection, your internet service provider logs every website visit. This data profile is frequently monetized without your direct knowledge. Imagine sending a letter written entirely in a completely unreadable code. Then, you place it inside a completely opaque, armored envelope. That is the core architecture of a virtual private network. It creates a secure, encrypted tunnel from device to server. The process begins right on your local device's VPN client. Your data is immediately scrambled using advanced mathematical encryption algorithms. Most premium services use AES 256, the global military standard. Breaking this code would take modern supercomputers billions of years. Next, this scrambled text is placed inside a normal packet. Engineers call this encapsulation, hiding the true destination completely. This package is routed using specific protocols like OpenVPN or WireGuard. WireGuard is much faster because it uses fewer lines of code. The encapsulated packet leaves your home router into the wild internet. If your ISP intercepts it, they only see random gibberish. The packet travels safely until it reaches the remote VPN server. This secure server strips the outer layer and decrypts the inside. The server then sends your original request to the actual website. To the website, the request appears to originate from the server. Your true location and identity are effectively hidden behind this proxy. The website sends back data, which undergoes the exact same process. Your local device decrypts it, showing you the requested web page. This routing lets users bypass local network content blocks entirely. Corporations utilize enterprise VPNs to protect sensitive internal company servers. The primary benefit is vastly superior privacy from commercial data brokers. It transforms risky public wireless points into completely secure access pathways. However, adding encryption layers naturally introduces measurable network transmission latency. You are not eliminating tracking, you are simply shifting the trust. If a provider keeps logs, your privacy could be severely compromised. Furthermore, software tools cannot protect you from downloading dangerous malware. Phishing still succeeds when people unknowingly trust fake websites. The industry is moving rapidly towards zero-trust network architectures globally. Quantum computing advances will soon threaten traditional mathematical encryption methods. Engineers are already developing brand-new post-quantum cryptographic standards today. Decentralized VPN networks are emerging, eliminating single points of corporate failure. Modern consumer hardware now includes dedicated chips for instant hardware encryption. In the future, secure tunnels might become entirely native web standards. A VPN is not a magical cloaking device for internet traffic. It is a practical, structured tool built on elegant math and engineering. Understanding how they function allows you to make much better security decisions. The modern web remains a massive web of complex public highways. But now, you know exactly how to build your own lane. Digital literacy is ultimately the ultimate shield in the modern age. Subscribe to Node 01 to keep decoding the world's technology.